Suppose you have two graphs. So we're going to have two curves given by two graphs. Let's call this y equals, say, f of x. And then we'll have some other graph, which we can call, say, y equals g of x. Now, we've already discussed how to find the area, say, from some x equals a to b. We know how to find, for example, the area under f of x. So if I want to find this area under f of x, if I want to find this area here, this is just going to be the integral from a to b of f of x dx, that definite integral. And likewise, we know how to find the area under g of x. If I want to find this area here, so maybe I'll cut this the other way. If I want to find this area, I can do that. I can find this area under g of x from a to b. But suppose now we want to instead find the area between the two graphs. I want to find what this area is. What is this area between these graphs? So maybe I'll try and fill that in here. What is this area between the graphs? And it's not hard to see, this is already quite suggestive, that the area between the graphs will just be all of the area under f of x minus the area under g of x, right? If you take all of the area minus this area on bottom, you're left with the area in between. So it's just this area right here. Or if I want to combine this into a single definite integral, I can say it's just the definite integral of f of x, of my f of x, minus g of x dx. Okay, so there we go. To find the area between two graphs, so here's the area between them, it's just the definite integral of f of x minus g of x. Now, what I should stress here, though, is that it's important that I put first the function on top. F of x is the function on top, and so I do the function on top minus g of x, because g of x is my function on bottom. Let's try an example of this and see it in action. Suppose, for example, I want to find the area between these two graphs. Between the graph of on top, I'll have y equals 2 minus x squared. That's just an upside down parabola, right? And then here on bottom, I'll have y equals just x squared, just the right-facing, upside-facing parabola. And I want to find what this area between these graphs is. What is the area between them? And so the formula already suggests that you just find the definite integral of 2 minus x squared, the graph on top, minus the graph on bottom, minus x squared dx. Except, what are my bounds? What is my a and what is my b? What is this value here, a on the left? And what is this value b on the right? Well, maybe if you graph this out, you can see on the graph where the intercept, maybe you can think of it. But if you aren't sure what a and b are, you can find a and b just by asking where do these two graphs intersect each other. That is, just solve where are these equations equal to each other. Where is 2 minus x squared equal to x squared? Let's have them equal to each other and solve for x. Move the minus x squared over, gives you 2 is 2x squared. Divide by 2, 1 is x squared. So what is x? X could be 1, although there's a second solution. What's the second solution? Well, whenever you square, there's two solutions, the positive and the negative. So a here is -1, and b here is +1. And if you graph this, you'll see, sure enough, they intersect at 1 and -1, -1 and 1. So from -1 to 1, this is the definite integral I want to solve. And so you can just do it. This is just the definite integral from -1 to 1 of 2 minus x squared minus another x squared. So that's minus 2x squareds, which comes out to be, I need to find the antiderivative. That's 2x minus 2/3 x cubed, because I increase x squared to x cubed, then the 3 comes down as divide by 3. Plug in my bounds. When I plug in 1, I get 2 minus 2/3. When I plug in -1, I get, so minus -1 gives me -2 plus, because -1 cubed is negative, times negatives plus, -2 plus 2/3. And when I simplify, I have 2 minus -2, so that's going to give me 4. And -2/3 minus 2/3, that's minus 4/3. So that's 12/3 minus 4/3. That gives me 8/3. 8/3. Okay, there we go. So the area between these is 8/3. Maybe I made some mistake in the arithmetic, but here's the setup. Function on the top minus the function on the bottom. From the left to the right, you find the antiderivative. Yeah, that looks good. And then you plug in the bounds, plugged in 1, plugged in -1. I think that looks good. We calculated the difference. That's how we do it. Let's try one more example. Suppose I have the graphs of sine of x and cosine of x. So let's do sine of x first. Sine of x begins at 0, and it goes up to 1, and then it comes back down. But I'm just going to look at the graph of sine of x just from 0 up until pi over 2, at which point it's up at 1. So this is the graph of y equals sine of x. And then think about the graph of cosine of x, which is kind of the opposite. It begins at 0, and at 0 it's at 1. And when x is 0, cosine is at 1, and then it comes down to 0. So this is the graph of y equals cosine of x. And what I want us to do is try to figure out what is the area between these graphs, between 0 and pi over 2. In particular, what is this area? What is this area between these graphs up through pi over 2? Okay, so let's take a look at this and see what we can come up with. Okay, remember, in order to find the area between, we have to have the setup of it's going to be the definite integral of the function on top minus the function on bottom. But here we get into a little bit of trouble, because here you began with cosine on top, sine on bottom, but by the time you get here to this midpoint, to pi over 4, it flips. So now sine is on top and cosine is on bottom. So how do we do this? Like, which one's on top, which one's on bottom? It changes. So what we're going to have to do is we're going to have to break up this problem into 2. First, we're going to talk about the area from 0 to pi over 4. From 0 to pi over 4, the function on top is cosine of x. The function on top is cosine of x, minus the function on bottom is sine of x. Then we'll add to that the area from pi over 4 to pi over 2, from pi over 4 to pi over 2, where that comes out to be just the function on top is sine of x, minus the function on bottom is now cosine of x, So we'll have to do this separately and solve each one and then add them together. Okay, so let's do that. Let's go ahead and first solve this first guy. So let me just move him down here and solve this first guy. I want to find this antiderivative. What is the antiderivative of cosine? The antiderivative of cosine is just sine of x, because the derivative of sine is cosine. What's the antiderivative of minus sine? Well, the derivative of cosine, of positive cosine, is negative sine. So this is just sine plus cosine is the antiderivative of cosine minus sine. So here, plugging in then 0 and pi over 4, we get, let's plug in pi over 4. Remember, that's like 45 degrees. On the unit circle, that's where both sine and cosine will be at root 2 over 2. Both of these are at half the square root of 2, root 2 over 2. Minus, now let's plug in 0. Sine at 0 on your unit circle, sine at 0 is equal to 0, plus cosine of 0 is 1. So let's simplify. half of root 2 plus half of root 2, that's just the square root of 2, minus 1, minus 1. Okay, that's what this first integral comes out to be. Now, we could similarly solve what the second integral comes out to be and add them together. But in this case, we actually have a bit of a shortcut, because if you look at the second area, maybe in this picture it's not great, but from how you understand of sine and cosine, you know that this second area will just be the mirror of the first. They're symmetric. The areas are the same. And so this second area should equal the first. You can calculate it out like we did here to verify, but it'll come out to be the same thing. The second area will also come out to be root 2 minus 1. So the total area of the 2 is just 2 times root 2 minus 1. Or if you prefer to write it, 2 root 2 minus 2. That is the total area here. Okay, so the big recap, how do you find the area between two graphs? It's just the area of the graph on top. It's just the definite integral of the function on top minus the function on bottom.